Okay, 4.2.1, we are creating an exponential model from this data in the form y equals a times b to the x. Remember, a is our starting value, and b is our growth factor. So first we're going to find b, then we're going to find a. Specifically, a has to be the population at time 0. But before we can work our way backwards from this 500, we have to know what our growth factor is. So for growth factor, let's keep it simple and do an is over was. The population is 8,000 at some point, and it was 500. So we divide these and get 16. But this growth of 16 is happening every 3 hours. Notice we're going from 2 hours all the way to 5. So we need to know what happens in between at 3 hours, 4 hours, or back at 1 hour, and more importantly, back at 0 hours. So we're taking this growth of 16, and we need to break it down into a smaller amount of time. So we need to figure out the time we want divided by the cycle that occurs on. So remember, you get a growth of 16 only every 3 hours, but we want to know only on a single hour. So we're going to take 16 and we want to know what it is 1 hour out of that 3 hour cycle. So that's how we get that fraction for the exponent. So we're going to take 16. We want 1 hour out of the 3 hour cycle. So we're going to punch this in a calculator. We're going to do 16 raised to the 1/3 power. And we get 2.5198. I know I'm going to a few decimals, but the more decimals we go, the more precise and exact our answer will be. Okay, so that means every hour we more than double. We almost do like 2.5 times as much every hour. So now we're going to use this to go find A. And what we're going to do is we're going to use what we know. We're going to use an XY coordinate. So here, think of this 2, 500. 2 is the X value of the time. 500 is the Y value of the population. So I'm going to substitute in my Y value for 500. I don't know my A value. Good news is I just found my growth factor, or B value, and now I'm going to raise that to a power of 2 because my X value, or the X coordinate, is 2. So now I'm going to take 2.5198, raise it to the second power. We get 6.3494. Let's do 6.3494, and that's still multiplied by A. And now we're just solving for A, so let's divide by 6.3494. And don't be scared of the number of decimals there. It's fine. We're letting the calculator do a lot of the work here. So 500 divided by 6.3494, we get 78.75. So 78.75. So let's call that 79. So now we have our A value, we have our B value. So we're going to write our exponential equation here as 79, 2.5198 to the power of x. So that gives us our starting value and our growth factor on a single hour interval. All right, so now we need to go down to example 4.2.1. So a TikTok goes viral. At 2 hours, it has 800 views. 5 hours, it has 6,400 views. We assume the growth is exponential. Find the function that models the growth. Perfect. So we're going to find B. We're going to do an is over was. At some point, the video has 6,400 views. It did previously, was at 800. So we got 64 divided by 8. We have a growth factor of 8, but that is happening on a 3 hour cycle from hour 2 to hour 5. So once again, we want a single hour cycle. So we're going to take 8 and we're going to raise it to the 1/3 power, better known as the cube root of 8, which we know is 2. So that means the views are doubling every single hour. Since they multiplied by 8 every 3 hours, We wanted 1 out of that cycle of 3. So times by 2 every hour. So let's use the coordinate 2, 800 for our x and y. So we're going to use y equals a times b to the x. 800 is our y. We don't know our starting value. Good news is now we know that our b value is 2. So we have 800 equals 2 squared is 4. So we're going to divide both sides by 4. And 800 divided by 4 is going to give us 200 as our a value. So our equation should say 200 starting value, doubling every hour, and repeat it.